Processing. A. The processor. The processor, also called the CPU or Central Processing Unit, is the brain of your computer. In PCs, it is built into a single chip, a small piece of silicon with a complex electrical circuit, called an integrated circuit, that executes instructions and coordinates the activities of all the other units. Three typical parts are: the control unit, which examines instructions from memory and executes them; the arithmetic and logic unit, ALU, which performs arithmetic and logical operations; the registers, high-speed units of memory used to store and control data. The speed of a processor is measured in gigahertz. Thus, a CPU running at 4 gigahertz can make about 4,000 million calculations a second. An internal clock sends out signals at fixed intervals to measure and synchronize the flow of data. The main circuit board is known as the motherboard. This contains the CPU, memory chips, expansion slots, and controllers for peripherals, connected by internal buses or PARDs that carry electronic signals. For example, the front side bus carries all data that passes from the CPU to other devices. Expansion slots allow you to install expansion cards which provide extra functions, for example, a video card or a modem. Laptops have PC cards the size of a credit card, which add features like sound, memory, and network capabilities. B. RAM or ROM. When you run a program, the CPU looks for it on the hard disk and transfers a copy into the RAM. RAM, random access memory, is temporary or volatile, that is, it holds data while your PC is working on it, but loses this data when the power is switched off. However, ROM, read-only memory, is permanent and contains instructions needed by the CPU. The BIOS, Basic Input/Output System, uses ROM to control communication with peripherals, for example, disk drives. The amount of RAM determines the number of programs you can run simultaneously and how fast they operate. It can be expanded by adding extra RAM chips. C. Units of memory. The electronic circuits in computers detect the difference between two states. On, the current passes through, or off, the current doesn't. They represent these states as 1 or 0. Each 1 or 0 is called a binary digit or bit. Bits are grouped into 8-digit codes that typically represent characters, letters, numbers, and symbols. 8 bits together are called a byte. For example, 01000001 is used for the character A. Computers use a standard code called ASCII for the binary representation of characters. In order to avoid complex calculations of bytes, we use bigger units. A kilobyte is 1024 bytes. A megabyte is 1024 kilobytes. A gigabyte is 1024 megabytes. A terabyte is 1024 gigabytes. We use these units to describe the RAM memory, the operating capacity of disks, and the size of a program or document.